All right, 6.6 is the concluding section of Chapter 6. It's where we're going to kind of take everything we've learned from all of the other sections and stick them all together. Because if you think back through all of the other sections that we have done so far in Chapter 6, none of them have we solved anything. We've done a lot of factoring and foiling and pulling out common factors and things like that, but we actually haven't found what x is in any of these problems. And that's because none of these have had an equals to 0 aspect to it. And so 6.6 is where we're going to solve quadratic equations with factoring. Quadratic equations are equations that can be written as ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a cannot equal 0. We have to have that specialization there that says a cannot equal 0, because if a equals 0, our x squared term goes away, and then we don't have a quadratic any longer. We have a linear equation. And so to be a quadratic, you have to have that x squared term in there. That's what makes you a quadratic. So just some general examples of what quadratics can look like. We've got the x squared plus 4x minus 12 equals 0. The second one, if you notice this example, we have a 2x squared minus 5x equals 0. This one doesn't have a plus c. That's okay. You don't always have three terms. It's not always a trinomial. Sometimes you'll have a binomial, or sometimes you can even have a monomial. And then the last one, you'll notice we're missing our middle term. We don't have an x term. We have an x squared term and a constant term. All of these are considered quadratics, though, because they do have that x squared term in them. All of these we could potentially solve if we needed to. And we're going to start actually solving these today to actually figure out what values of x make these quadratics work. For linear equations, when we solve for those, we get one answer. For quadratic equations, we can have two answers, or one answer, or 0 answers. A neat little trick that we may talk about later in a different section, but a neat little trick when you're solving any type of a polynomial equation, if you look at the highest variable on that polynomial, that will tell you the maximum number of answers you can get when you're actually solving it. So a quadratic, the biggest number of x values we could get to solve this is 2. You can get less, but that's the largest. If I gave you an x to the 4th polynomial, you could potentially have 4 different solutions for that polynomial. So just a neat little tidbit. One of the most important things is this zero factor property or zero product principle. Depending on which book or which website you look at, it's the same property or principle. It's just got some different terminology. But it states that if you have two things multiplying together, so an m times an n equals 0, then either m equals 0 or n equals 0. And we're going to use this zero product principle over and over and over again to solve our various quadratic equations today. Because the whole reason we've built up to this process in Chapter 6 is we're going to factor our quadratics. And when we factor our quadratics, we get a binomial times a binomial in general. Sometimes you'll have a monomial times a binomial. But either way, you have something times something, and we will always have that equal to 0. And the zero product principle then allows us to set each of our factors equal to 0 and solve for our x's. And that's how we're going to approach all of these problems. So the first types of problems you will encounter, they do actually most of the work for you. They have already factored the quadratic for you. And they give you the factored out binomial form. And notice it equals 0. It always has to equal 0. If you are given a problem that does not equal 0, your first thing is going to move everybody to one side so that it equals 0. Yes?
Can you go back to the factor real quick?
Not yet. You can open the laptop and log in, and you can look that way if you so choose. Okay. So for these bottom ones, these A and B, the first way we're going to solve this is simply by using our zero product principle. We have something times something equals 0. So what we're going to do is we're going to set each of our factors equal to 0 and then solve those little mini equations. So this is a factor, so it'll be x plus 3, and we set it equal to 0. This factor is x plus 4, and we set it equal to 0. These are linear equations now. We're just trying to isolate the x. Subtract the 3 over, and I get x equals negative 3. Subtract the 4 over, and I get x equals negative 4. Those are the two possible solutions for this quadratic equation. And on Pearson, the way that you type them in is it tells you to type in multiple answers by using a comma in between. You don't have to put any type of a space or anything like that, and the order does not matter. So if you type in negative 3, comma, negative 4, that's correct. If you type in negative 4, comma, negative 3, that is also correct. But when they've done the factoring for you, it's pretty straightforward. Are there questions on that one? Now, obviously, the binomials themselves are a little bit more complicated. We have a 2x plus 3, and we have a 5x minus 7. Again, though, we're going to set each of our binomials equal to 0, and then we will solve them. The whole goal when we are solving these is to get our variable by itself. So for the 2x plus 3 equals 0, the first thing I'm going to do is subtract the 3, giving me a 2x equals negative 3. Then I would divide both sides by 2, giving me x equals a negative 3 halves. I do not want to type in a negative 1.5. I don't want to type in negative 1 and 1 half. You want to have simplified fractions, and if they're improper, that is totally okay as long as they're still simplified. 3 has nothing in common with 2, so this is a simplified improper fraction. You will get fractional answers, and that is okay. Now we do a very similar process for the 5x minus 7. We add the 7. We get 5x equals 7, divide by 5, and we get x equals 7/5. Are there any questions on how we're using the zero product principle to solve for these? Okay. Then here's the bulk of the notes, right here. Obviously, those first two examples are about as easy as they're going to come because they've already done the factoring process for you. But we have spent all of Chapter 6 learning all these different ways to factor, where we factor when A is 1, or where we factor when A is not 1, where we factor by grouping, where we do trial and error, and all this different stuff. Now we're going to use all those different methods in order to do our own factoring to solve these quadratics. In college algebra, you will learn lots of different methods to solve quadratics, but in here we're going to focus on the factoring, at least for right now. So, solving quadratics by using factoring. The first thing that you always have to do is make sure your quadratic is written in that ax squared plus bx plus c equals 0. If it's equal to anything else besides 0, you're going to have to move stuff around until you get 0 on that right-hand side. Always. Step 2 is factor. Use one of the methods that we have learned throughout Chapter 6. You don't always have to use the same method. You use whichever one comes to you and makes the most sense for the given problem. Step 3, we set each of our factors equal to 0. We do this using our zero product principle, just like we just did in the previous examples. Step 4, we solve each of those factors. And step 5 is always, like, the best method is to check your solutions by plugging them into the original and making sure you actually get a true statement. On some of these I do check my work, on others I don't. It's mostly just for space or time purposes. But on a quiz, a homework assignment, a test, especially if you know you've gone through and done all of your problems on the test and you still have more time, go back and make sure your answers work. Plug them into the original. Make sure you actually get the true statements. Because maybe you accidentally dropped a negative somewhere and it messed everything up, but you didn't catch it. And so if you have the time, use the time wisely so that you can figure it out. So, write the quadratic in ax plus bx plus c form, factor it, set each of your factors equal to 0, solve those factors, aka get x by itself, and then test your solutions. And we're going to do a handful of these. Try and give you a little bit of one using everything I could find. Are we ready to try one? Try and leave those steps up there for the first one. X squared plus 10x plus 28 equals 4. So in general, this looks mostly right. We do have an x squared, an x, and then a constant term. The only thing that's wrong to get started with is it equals 4, not equal 1, or 0, excuse me. So the first thing we're going to do is we're going to subtract that 4 over to our left-hand side so that we can have it equal to 0. And 28 take away 4 will give me 24. Now we're going to factor. We're going to factor into our binomials. And when we factor into our binomials, my x squared is going to split and become the first term in my binomials, where I have an x and an x. Then I look at the sign that is in front of my c term. The sign is positive. When the sign is positive, it tells me the signs inside are both the same. Then I look at the sign in front of my b term, and that tells me what those signs are. They're both going to be positive. Then I need factors of 24 that are going to add up to give me 10. So that's 1 times 24, or 2 times 12, 3 times 8, 4 times 6. I think that's all of them. So which pair of factors is going to add up to give me 10? 4 and 6. 4 plus 6 is going to give me 10. Since they're both positive, it does not matter if I put the 4 in the first one or in the second one. And I can always double check my work here by doing foiling. If I did my first, outer, inner, last, I could make sure I get back up to that trinomial. Now previously, in all the other sections we've done in Chapter 6, we wouldn't have the equal sign. It would just say factor and we would be done. But now that we have the equals to 0 and it's specifically telling us to solve, now we go on to step 3, which is our zero product principle. I let my x plus 4 equal 0, and I let my x plus 6 equal 0. Subtract the 4, and I get x is negative 4. Subtract the 6, and I get x is negative 6. These are the two solutions. And if I wanted to test these solutions, I could plug them back into the original and make sure that they work. I'm going to ask you to have a little bit of faith with me today and know that I checked my answers with the book. They do work. Questions on this one? Questions on any of the steps? Clarification? Okay, let me give you another one. Same rules, same steps. This one obviously looks different. We have a 3x squared equals 12x. It's still considered a quadratic because we have an x squared term in it. So our whole goal still is to start by getting it to look like ax squared plus bx plus c equals 0. So I'm going to subtract the 12x to move it over to the left-hand side. That way I have everything set equal to 0. Now, the form that we're going to use for factoring this is obviously going to be different because we're not factoring a trinomial. We only have two terms. So what do we need to do in order to factor this?
C and 0.
Hold on, I heard two different things.
C term?
Okay, we don't have a C term. We don't have to have a C term. We learned how to factor when there was just two terms. What did we do? Like, what's always the first thing we ask when we're looking at these and starting to factor? What do these things have in common? That's exactly right. So what does 3x squared and negative 12x have in common that I can pull out? A 3x. That's exactly right. Always look to see if there's a common factor. That will leave me with an x inside minus 4. And in previous sections, we would be done, again, because we wouldn't have the equals part, and that's completely factored. But now we have something times something equals 0. We can set each of our factors equal to 0 using our zero product principle. So I can set 3x equal to 0. I can set x minus 4 equal to 0. Now the question is, what is this 3 doing to this x over here? What operation is happening here? Addition, subtraction, multiplication, or division? Multiplication. So the opposite of multiplication is division. 0 divided by anything is 0. Over here, I just add the 4 over and I get x equals 4. So even without having a C term, you're able to factor it. Or the other way you could see that is if you didn't have a B term, that middle term, that X term, you would still do the same thing. Either you're going to have a perfect square binomial, or you're going to have an opportunity to pull out something that they both have in common. And we'll see one in a minute that doesn't have a middle term. Are there questions on this one? Okay. Got some space over here, so let's just stick C over here. This time we're going to use y as our variable instead of x. It does not really matter what variable they give you. You just use whatever they give you. Sometimes they'll give you n or a, or default's usually the x, but just pay attention to what variable they use. So what am I going to do first? That's right, I'm going to add 11y over. That way I have everything on the left-hand side. 5y plus 11y will give me 16y. Do we notice anything about all of these terms?
You can take the 4 out.
Yeah, they all have a factor of 4. Now, what's different about this one than the one we just did is the one on the left, B, had a 3x that we were able to pull out. So one of the terms that we pulled out had the variable. Here, we're not pulling out any variables. We're just pulling out a constant. So we can actually think about it in terms of just dividing everything on both sides by 4. Because if we do it to one side and we do it to the other side, that's totally fair game. So if we divide everything by 4, the factor of 4 is just going to fall away. Over here, we could not do that because we didn't pull out just a constant. We pulled out a variable as well. If you're just pulling out a constant and everything is set equal to 0, you can actually think about just dividing everything, including the 0, by that constant, which will leave us with a y squared plus 4y minus 5 equals 0. If you did not recognize that a 4 pulled out of that, you could still factor it. It's a little bit harder because we have our a is equal to 4 instead of 1, but it's still factorable, and you're still going to get the same solutions in the long run. So let's set up our factors. My first term's y squared, so I know I'm going to have a y and a y. My sign in front of my C term is negative, meaning I'm going to have a positive and a negative. And here's the nice thing. 5 is prime. So there's only one set of factors for it. It's 1 times 5. So then the question becomes, where do I put my 1 and where do I put my 5? Well, I look here at the middle term. It's a plus 4. That means I need to have more positives than negatives, so I'm going to put the 5 with the positive and the 1 with the negative. And again, I can check this using the FOIL method, and if I do my outer, I get a negative y. My inner, I get a positive 4y, or a positive 5y, which would result in the positive 4y. If I had switched these, I would have negative 5y plus y, and that's how you would know to move them. But at this point, we have a factor times a factor equals 0. Zero product principle, set each of these equal to 0 and solve. Subtract the 5, add the 1. Questions, comments, clarifications? Okay, let's do another one. This one we have z squared equals 144. So we have an x term, like a squared term. We have a z squared. And this time we have our constant. We don't have just a single z term. We're missing that middle term, and that's okay. Your steps are always the same, regardless of which way your quadratic is going to go. The first step is going to be to get everything to the left-hand side, so I'm going to subtract that 144 over. Now, what does this look like? We have something squared minus 144. And we had something in a previous section, difference of squares, where if it looks like a squared minus b squared, this can factor into a minus b, a plus b. So then the question becomes, what's our a and what's our b? Well, our a in this case would be the z, and our b would be, well, what times what gives me 144? 12. 12 times 12 gives me 144. And if you don't know, that's where you use your square root button on your calculator. So if this is z squared minus 12 squared, then I can write this as z minus 12, z plus 12. Difference of squares. So z minus 12 equals 0, using my zero product principle, and z plus 12 equals 0. For the one on the left, I would add the z over, finding 12 as a solution. For the one on the right, I would subtract my 12 over, giving me a negative 12 as a solution. Questions on that one? All the different things that we've learned with factoring come up here. All the special forms. I say that, all the special forms. This one's solving quadratic, so your cubic stuff isn't going to come up in 6-6. But factoring out common factors, zero product principle, difference of squares, all of that's still at play.